Okay, now we're going to look at Leaps library. Don't think Leaps library is there, so I need to install Leaps. Okay. All right, so the methods in Leaps library. So it gives you leap forward, leap backward, leap forward, and leap sequential, leap SEQ. Those are the three methods that we already discussed, right? And then we have a query parameter that is the maximum number of predictors you want. So if the data set has like 250 variables, and you want a model with no more than 15 variables, and you can say Vmax is 15. So to then generate a model with just 15 variables. Okay? And you can specify metric, a string that specifies the summary metric that will be used to select. So you can have MAE, RMSE, which is the default, or you can use R squared. And for classification, you can use accuracy or kappa method. We'll talk about that later. And you can also do with some special tweaks, we can do AUC and so on. All right, let's look at backward elimination. Set C1. Okay, we should have done set C here as well when we did the cross validation. In cross validation, here, cross validation is done at random, so we should have set C here a lot. Well, for the purpose of generating the same output. Otherwise, it's set C is not required. Okay. All right. Now, set C equal to 1. Suppose I want to do backward elimination. Okay. So call red backward. And I suppose that we want to use the same cross-validation approach. So we already have the train control, TR control set up, okay, which says method is CV and we want 10 folds, right? So we will use that control. So we're going to do train. And the formula is price, and we want to consider all the variables, and data is equal to the entire data set, not just train. Okay, because we're going to use cross validation. Okay, and then say method equal to it is leap backward. So this is going to be the method backward from the leap library. So that's what we're going to use. Okay. And you're going to use train control, TR control. Okay, we're going to use the same TR control, which was what? car.cv.control. And then we're going to use tune grid. Okay. And the tune grid has to be a data frame. So we do data frame. Okay. Then we max equal to 1 to 5. So which means it's going to consider 1, 2, 3, 4, 5 as the number of maximum variables. So you're we're going to try 5 different Nmax values. Okay. It will run cross-validation for Nmax equal to 1. So that means you only select the best one variable. And then Nmax equal to 2, then Nmax equal to 3, and so on. So that's what the grid here means. So Nvmax is from 1 to 5. So after that, let's say you want cars are read backward, the sub. Always practice. So it should be B backward with B uppercase. Okay. So here, so it ran with just one variable, with 2 variables, 3, 4, and 5. You have the set here, the result. Okay. Now, if you want to look at the best result, we can feed off what the best Q value is. Okay. So best Q value is, we need to make this into an integer. Car.red. Backward best Q. Then we can say, all right, so car got backwards. Then it has the results in it. Okay. Now inside the results, there's a bunch of them. Okay, what is the Nvmax value? RMS equal R squared, and so on. So if you want R squared, then take R squared. Okay. Now, again, this is going to have R squared, 5 of them, one for each Nvmax. Okay. And we want to get the best one. So that's why we save the best tune here. So if you do best dot tune, so that will give you the best R squared value. Now let's run a forward selection. I'm going to copy paste this. So this is lead forward. And let's keep everything the same. We need to give a different name here. Forward. Again, I have a typo. So we can look at each of these individually and find out which one is the maximum or which one is the minimum, depending upon the measure. Yeah. So let's say that we want to look at the best backward elimination result and the best forward selection result. Okay. So let's also say that we want RMSE and R square. So if we did forward, red backward, right? And then result RMSE, the best tune. So that's going to give us the best RMSE, well, RMSE for the best, okay, which is okay. But what about if you want the best R square? Well, anyway, let's first set up a table here. Say car is the table. We want to create a table consisting of the results of backward and the results of forward. Okay? So we're going to create a data frame. And we're going to say model equal to backward. So that's the model that we are, because the model will be the name of the column, the value will be backward. And then RMSE equal to that one. Okay. And then let's say that for that we want R squared, R is cubed, R squared and then we print the car is the table, and let's take a look at it. So we have model is backward, RMSE, and R is. Okay, so that's from the backward, the best backward model that we want. And now let's look at the forward. And now let's say that we don't want to look at the best tune, but we want to select the best awesome. Best awesome. So best RSQ, let's say forward dot best RSQ, right? So we want to look at car dot that one, okay, results, okay, R square. this R squared has 5 of them, 1, 4, and max 1, 2, 3, 4, and 5. Now we want the best out of this. So we have which, there is the which max and which min. So which of these is, okay, so you run that, it gives you the 4 plus is the best. And now let's say that we want to append this result to this call accuracy table. Call accuracy table, so that we do an R1. Call accuracy table. R1 we take call accuracy table. Now it's going to add to the bottom. Doesn't make any sense. Okay. All right. So you need data frame. You need to have the same names like what we did before. So model equal to forward. Okay. And I'm going to copy and paste this. Now, RSE is going to be for forward. And this is our best tune, we're going to use this. So we are actually mixing and matching, so it's not really good practice. But I want to show you 2 ways of building it. You can use the best tune, or you can choose your own criteria. Forward. Do I have everything right? Forward. So I need a close parenthesis here. That is for the data frame. That's on white. Okay. All right. So now if I print color accuracy table, so it's going to have 2 of them. Looks like it's the same model. So they both are 4, so it gives you the same result. So you have the step method from stats library. Okay. And you can use that with the regular validate and train data sets. Or you can use Caret and Leap together. In Caret, you have the opportunity to use the cross-validation approach, where you specify how many folds you want, and then you use the train method of Caret, and then the stepwise method you can use from the Leap library. So Leap backward, Leap forward, and Leap sequence. SEQ. And again, and the results that you get, you can dive into the results list and select the particular metric that you want and build them into a data frame and then use it for further reporting results. So that's what we covered here. The end of chapter 6. And have a nice spring break, sir. And we're going to have, I don't know exact date, but